everyone. In today's lesson, we're going to talk a little bit more about motion of a line. So we have to define a few new things. First thing being acceleration. So a positive or negative change in velocity over time is what the definition of acceleration is. If you've taken a physics class before, you've probably heard of something like, I don't know, meters per second squared. So that squared business tells us the acceleration, how fast something is changing over time. So if we have a positive acceleration, it means that our change in velocity over time is positive and we're moving right. If we have a negative acceleration, we have a negative change in velocity over time, but we'd be moving left. So a positive acceleration occurs when acceleration is greater than zero. A negative acceleration occurs when acceleration is less than zero. Oh, and I forgot about the acceleration formula. So the acceleration is found by taking the derivative of the velocity function, v prime of t. So the questions will ask you things like, when is the particle slowing down or when is it speeding up? So a particle slows down when the velocity and the acceleration have different signs. And it speeds up when the velocity and the acceleration have the same signs. So what do I mean by same signs and different signs? So if the velocity is positive and the acceleration is negative, or the velocity is negative and the acceleration is positive, those are opposite signs, therefore I'll have a slowing down effect. If I have a velocity that's positive but an acceleration that's positive, same signs, both positive, or a velocity that's negative and an acceleration that's negative, still same signs, then we will have a speeding up situation. So keep this in your notebook so you can have it nice and neat so you can reference it in the future. So let's do an example now together and put all of this into practice. Okay, problem number one, or example, says a particle moves along a horizontal line according to the function s of t equals this function where time is greater than zero, time is measured in seconds, and s of t is measured in meters. So find the acceleration function at any given time t is the first piece of information. So we know by definition the acceleration function is the derivative of the velocity function. So what we're first going to have to do is find the velocity function. So the v of t function is found by taking the derivative of s of t, the original function. So we're just going to use the power rule here to find our first derivative. So 2t to the third, the derivative of that is 6t squared. The derivative of negative 15t squared is negative 30t. The derivative of 24t is 24. And the derivative of 8 is 0. So now if I want to find a of t, the acceleration function, I'm going to take the derivative of v of t. So we're going to take the derivative of this piece, and that will be my acceleration function. So the derivative of 6t squared is 12t, and the derivative of negative 30t is negative 30, and the derivative of 24 is a constant, so we don't need to write that, it's 0. So this is your answer for part A. So if you want to take some notes, the acceleration function is the derivative of v of t. Or it's the second derivative of the s of t, or sometimes referred to as my x of t function. Okay, so part B is now saying, what is the instantaneous acceleration at, it should say not after 4 seconds, it should say at 4 seconds. So I want to know at 4 seconds, what is my acceleration? So all you're going to do is plug 4 into my acceleration function. So if this is my acceleration function, everywhere I see a t, I'm going to put a 4. So I'm going to go ahead and put that in there as well. So we have 12 times 4 minus 30. 12 times 4 is 48. 48 minus 30 is 18. So 18 is my acceleration. Now, I'd like to explain what that means. So we have a positive acceleration, right? So positive acceleration. Now, that doesn't necessarily mean that we're speeding up. Remember, in order to speed up, we have to have the same signs in velocity as well. So a positive acceleration of, we could say, 18 meters per second squared. So we're changing the velocity by 18 meters per second squared in a positive direction. So we'd be moving to the right in this case. Okay, so that's really what all that 18 means. So now to find where the particle is speeding up and slowing down, we have to compare a v of t number line with an a of t number line. So the first thing you want to do for steps, if you need to write them, is find v of t and set it equal to 0. Then make a sign chart. Then we're going to find a of t, and we're going to set that equal to 0. And we're going to make a sign chart as well. And then we're going to compare them. So we'll call step 3 comparing. Maybe we'll do that on another slide if I run out of room. So we already found, if we go back to part 1, where we've already found v of t. So I'm just going to copy v of t from up here. So we have 0, because we said we need to set it equal to 0, equals 6t squared minus 30t plus 24. And we're going to factor and solve. So it looks as though I could take out a GCF of 6 out of all of them. And I have t squared minus 5t plus 4. And add multiply tells us we have t minus 4 and t minus 1. And if we do a t-chart, this one we reject, we get positive 4 and positive 1. Now, we did this yesterday. This is the same problem, except this is where we are changing direction, right? V of t equals to 0 is where we're changing direction, where we are at rest, okay? So now we're going to do the same thing, but for the a of t function. So my a of t, I'm just going to use this one over here. My a of t function is 12t minus 30. And we're going to set that equal to 0. So 0 equals 12t minus 30. We're going to solve this equation by adding 30 to both sides. So we get 30 equals 12t. Divide both pieces by 12. And I can reduce this by dividing top and bottom by 6. So I have 5 over 2. And that is where I have acceleration equal to 0. So I am not changing velocity over time. Okay, let's now figure out, well, where is the particle speeding up and slowing down? So in order to do that, we need to use this information and we need to compare it. So the first thing that we need to do is draw a number line for v of t. So we'll put 0 here and an arrow. So here's my v of t number line. And then right underneath it, we're going to draw a number line for a of t. Okay? And what we're going to do is we're going to place the values of where the a of t and v of t were equal to 0. So we had 1 and 4 for v of t. That's where it changed direction. And then for a of t, we had 5 halves, which is about 2.5. So we'll put that here, and we'll call this 5 halves, approximately 2.5. Notice I put this 5 halves right in line with where it should be, right? If this is 1 and this is 4, this should be about 5 halves. So it's really important that you set this up nice and pretty. So now what we're going to do is do a sign chart. So we need to test a value between 0 and 1, 1 and 4, and greater than 4 into v of t. And we need to see if it's positive or negative. So I'm going to test a value between 0 and 1 to say be 0.5. Between 1 and 4, I'll test 3, and after 4, I'll test 5. So I'm going into my v of t function, and I'm finding v of 0.5. I'm finding v of 3, and I'm finding v of 5. And I'm going to decide if they're positive or negative. Then I'm going to do the same thing for the a of t function. So for a of t, I can try 2 even, that's fine. I could put 2. And after 2.5, I could try 5 also. Notice where I'm putting these test values. It's really important that you line them up accordingly, otherwise you're going to get yourself confused. My suggestion even would be not even write them, just test them, and then you'll see that it's a little bit clearer. So we'll test a of 2, and let's test a of 5. So take a couple minutes and test them into the equations that we found, and then hit resume when you're ready for the answer. Okay, so for v of 0.5, you should have gotten 10.5. For v of 3, you should have gotten negative 12. And v of 5, you should have gotten 24. A of 2 is negative 6. And a of 5 is 30. So 10.5 is positive when I plugged in 0.5. Therefore, here is going to have plus signs, right? Then, because when I plugged in 3, I got a negative 12, here is going to have negative signs. And then at 5, since I plugged in 5, I got a positive 24. Everything greater than 4 will be a plus sign. And then a of 2 was a negative 6. Between here and here is going to have negative signs. And last but not least, since a of 5 was positive 30, from here to here is going to have positive signs. So now, to decide if we are speeding up or slowing down, we just have to look for same signs and different signs. So to speed up, we need same signs. And to slow down, we need opposite or different signs. So the best way to compare them is to draw in vertical lines at where v of t is equal to 0, so at these points here, 1 and 4, and where a of t is equal to 0, those three main points we used before. So we're going to put our lines straight through here, and straight through here. And all we care about is comparing the signs in between these lines. So from here to here is one area, from 0 to 1. So notice positive, negative. So different signs. Therefore, we are slowing down between 0 and 1. And we write that in interval notation as 0 to 1. Now let's go to the second space. So from 1, but now we're ending at 2.5. So from 1 to 2.5, we have a minus and a minus. Same signs, therefore we're speeding up. So 1 to 2.5. Okay. And then from 2.5 to 4, minus and positive is opposite signs. So 2.5 to 4, we're slowing down. So union 2.5 to 4. You could put 5 halves, same thing. And then from 4 on, plus, plus, same signs. So union 4 to infinity is where we would be speeding up. All right, that's it. I'd actually like you guys to go to the next page and try one on your own. Hit resume when you're ready for the answer. Okay, here they are. Feel free to pause the video and jot down any questions that you have, and we can go over them tomorrow. All right, here's the answer to part C. So a couple things here. The values where v of t was equal to 0, I got 11/3 and 1. And where a of t was equal to 0, I got 7/3. So I put the 1 and 11/3 on the v of t number line, and I put the 7/3 on the a of t number line, and I did some test values. Notice I didn't actually write them in this time. So between 0 and 1, I tested 0.5, I got positive. Between 1 and 11/3, I tested 2, and I got negative. And bigger than 11/3, I tested 5, and I got a positive 32. Between 0 and 7/3, I tested a positive 1 and got a negative 16. And bigger than 7/3, I tested 5, and I got a positive 32. So wherever I had the same signs, which were here and here, is where I sped up, right, from 1 to 7/3 and from 11/3 on. And where I had different signs, so from 0 to 1, different signs, and from 7/3 to 11/3 was where I slowed down. All right, so if you need to pause the video to jot any of this down, feel free to do so. And if you have any questions, jot those down as well, and we'll ask us in class tomorrow. All right, have a good night.